Good afternoon, everybody. Welcome back to the next session. And it's a pleasure for me to be over here for the second cycle capacity building program under the aegis of DAVCAE New Delhi. So I will try my best to bring the concept home, and for this I require your cooperation and active participation for the program effective and fruitful. So before I am proceed to my topic directly, think about these two questions. What makes few people abnormally tall while others abnormally short? So this is the picture depicted here. And second one is how is it that some days you are in a good mood, whereas the other days your mood is not as good. Go through the picture over here. So can anybody? Hormones. Yes. Yes. Next. So the correct answer is hormones. So the growth hormone in excess during the growth years, that is during childhood stage, gives rise that leads to a disease called gigantism, and whereas the deficiency or less secretion of growth hormone from the pituitary gland that leads to a disease called dwarfism. On the other hand, estrogen makes a woman feel good. Below levels of it can make them fat. So all these are effects of hormones. So let us learn more about it. So today my topic is hormones and their mechanism of action. Next. So before going to detail of hormones and endocrine glands and mechanism of hormone action, we should know about the glands from which hormones are secreted. So the endocrine system is made up of the endocrine glands that secrete hormones. Endocrine glands are those glands which have no duct. That is, endocrine glands are called ductless glands, which secrete only hormones and directly into the bloodstream. So there's although there are 8 major endocrine glands scattered throughout the body, they are still considered to be a one system because they have similar functions, similar mechanism of influence, and many important interrelations. Some glands also have non-endocrine regions that have functions other than hormone secretion. For example, the pancreas is known as heterocrine gland or composite gland or mixed gland because pancreas has both the exocrine part as well as endocrine part. Exocrine part secretes enzymes, whereas endocrine part secretes hormones. Other than pancreas, the ovaries and testes, they also secrete hormones, reproductive hormones, sex hormones, and all. The main function of testes and ovaries to produce sperms and ova respectively. Some organs such as stomach, intestine, and heart produce hormones, but their primary function is not hormone secretion. So these are not endocrine glands, although they secrete hormones. Next. Next, types of hormones. On the basis of their chemical nature, hormones can be divided into 4 groups: peptides, polypeptides, and protein hormones. For example, insulin, glucagon, pituitary hormones, and hypothalamic hormones, etc., under this category. Number 2, steroids, cortisol, testosterone, estradiol, and progesterone. These are under steroid. Next, number three, iodothyronine, that is thyroid hormone. And number four, amino acid derivatives, that epinephrine. Main two types of hormones are peptide hormones and steroid hormones. Peptide hormones are composed of amino acids and are soluble in water. And peptide hormones are unable to pass through the cell membrane as it contains a phospholipid bilayer. Cell membrane is composed of phospholipid bilayer that stops the fat insoluble molecules from diffusing into the cell. Insulin is an important peptide hormone produced by the pancreas. I am coming to the next about the secretion of insulin from the pancreas. Steroid hormones, unlike peptide hormones, steroid hormones are fat soluble and are able to pass through a sex membrane. And sex hormones such as testosterone, estrogen, and progesterone are examples of steroid hormones. Now, have a look the location of endocrine glands in human body: hypothalamus, pituitary gland, pineal gland, thymus, thyroid and parathyroid gland, adrenal gland, pancreas, ovary, testes, etc. These are the major endocrine glands located in different parts of the human body. So endocrine glands in humans, these are the this is the list of endocrine glands present over here. Endocrine system consists of the following glands: hypothalamus, pituitary gland, pineal gland, thyroid gland, parathyroid glands, thymus, adrenal glands, pancreas, ovaries, and testes. Hypothalamus. So the hypothalamus is the region in the ventral brain which coordinates the endocrine system. It receives many signals from the various regions of the brain and in return releases both releasing and inhibiting hormones. So hypothalamus releases mainly two types of hormones: releasing hormone and inhibitory hormone, which then act on the pituitary gland to direct the functions of the thyroid gland, adrenal gland, and reproductive glands, and to influence growth, fluid glands, and milk production. Not only these glands, so hypothalamus direct the function of so many types of glands. It is also involved in the non-endocrine functions of temperature regulation, regulation of the autonomic nervous system, and the control of appetite. So this is the non-endocrine function of the hypothalamus. So before coming, before it, just I would like to share with you that hypothalamus is known as master of the master gland. You know it very well. So why it is called so? Because we know that master gland is known as pituitary gland, and hypothalamus controls the hypothalamus secretion of hormones from the pituitary glands, and that is why hypothalamus is known as master of the master gland. Hypothalamus is the yes. Yes, yes. Absolutely right. So hormones secreted by hypothalamus. The anterior region of the hypothalamus is responsible for hormone secretion. The nucleus present in this region leads to this process, and the important hormones secreted by hypothalamus are: number one, corticotropin releasing hormone. This hormone is responsible for the regulation of metabolic and immune response. Number two, thyrotropin releasing hormone. It triggers the pituitary gland to release a thyroid stimulating hormone, which plays a major role in the functioning of organs of the body such as heart, muscles, etc. Number three, gonadotropin release. It stimulates the pituitary gland to release several reproductive hormones, that is the sex hormones. Next, oxytocin. It is involved in several processes such as lactation, childbirth, regulating sleep cycles, maintaining body temperature. And somatostatin, this hormone is also known as growth hormone inhibiting hormone. Growth hormone inhibiting hormone. Okay, so this hormone is also known as growth hormone inhibiting hormone. That means it inhibits the secretion of growth hormone. It regulates the endocrine system and affects the neurotransmission and cell proliferation by interacting with G protein coupled receptor. Next, this is the master gland, that is pituitary gland. It is also known as hypophysis. So the pituitary gland or hypophysis is a small organ about the size of a pea, sits below the brain in a midline pocket or fossa of the sphenoid known as sella turcica. Embryologically, anatomically, and functionally, the pituitary gland is divided into two lobes, namely anterior pituitary and posterior pituitary. So it is one of the vital glands of our body as it controls a lot of vital hormones such as thyroid stimulating hormones, puberty hormone, growth hormone, prolactin hormone, and a lot several more hormones. There is a huge number of hormones secreted by pituitary glands. So hormones secreted by pituitary gland, first of all, hormones secreted by anterior pituitary. The anterior pituitary is responsible for the synthesis and secretion of several key hormones in the body. These hormones are human growth hormone, that is we generally known as GH, that is normally we say growth hormone, responsible for the growth and repair of all the cells in the body. TSH, that is thyroid stimulating hormone, influences the thyroid gland. Further release of thyroxine, its own hormone, and TSH is also called thyrotropin. Adrenocorticotropic hormone or ACTH influences the adrenal gland to release of cortisol or the stress hormone. ACTH also known as corticotropin. Luteinizing hormone or LH and follicle stimulating hormone or FSH, collectively known as gonadotropin, and LH and FSH control the sexual and reproductive characteristics in males and females. Prolactin here produces milk in the breast, though it is present at all times. The secretion is increased during and just after pregnancy. Melanocyte stimulating hormone, also known as MSH, it is involved in the stimulation of the production of melanin pigment by skin and hair. Then the hormones produced by posterior pituitary hormone. The posterior pituitary is responsible for the storage and secretion of two very important hormones, that is anti-diuretic hormone, that is ADH, that controls the water balance of the body and by affecting reabsorption of water by the kidneys. It is very, very important. It is also known as vasopressin. And oxytocin, it controls the certain aspects of pregnancy and childbirth, such as uterine contraction and production of milk. So in this context, I just share with you some hormones are known as happy hormones or love hormones. Dopamine, oxytocin, and endorphin, etc. Next, pineal gland. Pineal gland is a fine cone-shaped small gland located in the middle of the human brain, in between the two hemispheres, only called third eye for many reasons. That is Shiva's third eye. Okay. And for many reasons, including its location deep in the center of the brain and its connection to light via circadian rhythm, that is 24 hours. Yes. And melatonin secretion, many spiritual traditions believe it serves as a connection between the physical and spiritual world. There is a connection. It may be. And it is the major site for melatonin secretion, which regulates the body's internal clock, that is circadian rhythm. Next, thyroid gland. The thyroid gland is composed of two lobes, that is, it is a butterfly-like structure, which are located on either side of the trachea. Both the lobes are interconnected with a thin flap-like structure that is called isthmus. It is a connective, one type of connective tissue. The thyroid gland is composed of follicles and stromal tissue. Each thyroid follicle is composed of follicular cells enclosing a cavity, and these follicular cells synthesize two types of hormones. Number one, tetraiodothyronine or thyroxine, that is, it is also symbolized as T4, and triiodothyronine or T3. Iodine is essential for the normal rate of hormone secretion or hormone synthesis by the thyroid gland. If there is any deficiency of iodine in the thyroid gland, then that leads to a disease that is called goiter, that is swelling of thyroid gland and the throat portion. Next, parathyroid glands, four small masses of epithelial tissue that are embedded in the connective tissue capsule on the posterior surface of the thyroid gland, and these are called parathyroid glands. And these are very small, and it cannot be seen from front side. It is on the posterior side of the thyroid gland. They secrete parathyroid hormone. It is also known as parathormone. Parathyroid hormone is the most important regulator of blood and calcium level. The hormone is secreted in a response to low blood calcium levels, and its effect is to increase these levels. So when calcium level of blood is lower, then the parathormone hormone is secreted to balance it. Thymus. The thymus is a lobular structure located between lungs behind the sternum on the ventral side of aorta. The thymus plays a major role in the development of the immune system. This gland secretes the peptide hormones called thymosin. Thymosin play a major role in the differentiation of T lymphocytes, which provide cell-mediated immunity. In addition, thymosin also promote production of antibodies to provide humoral immunity. Thymus is degenerated in old individuals, resulting in a decreased production of thymosin. And as a result of this, the immune system or immune responses of old persons become weak. Next, adrenal glands. Most important glands, it is also known as suprarenal glands, as it is as these are located at the top of each kidney. The adrenal or suprarenal gland is paired with one gland located near the upper portion of each kidney. Each gland is divided into an outer cortex and inner medulla, just like that of kidney and pituitary gland. So these are developed from different embryonic tissues and secrete different hormones. The hypothalamus of the brain influences both portions of the adrenal gland, but by different mechanisms. The adrenal cortex is regulated by negative feedback involving the hypothalamus and adrenocorticotropic hormone. The medulla is regulated by nerve impulses from the hypothalamus. Next, some hormones which are secreted by adrenal cortex region. The adrenal cortex secretes many hormones commonly known as corticoids. The corticoids, which are involved in carbohydrate metabolism, are called glucocorticoids. In our body, cortisol is the main glucocorticoid. Corticoids, which regulate the balance of water and electrolytes in our body, are called mineralocorticoids. And in our body, aldosterone is the main mineralocorticoid. Glucocorticoids stimulate gluconeogenesis, lipolysis, and proteolysis, inhibit the cellular uptake and utilization of amino acids. Cortisol is also involved in maintaining the cardiovascular system as well as the kidney functions. Glucocorticoids, particularly cortisol, produces anti-inflammatory reactions and suppresses the immune system. Cortisol stimulates the RBC production. Aldosterone acts mainly as the renal tubes and stimulates the reabsorption of sodium and water and excretion of potassium and phosphate. Thus, aldosterone helps in the maintenance of electrolytes, body fluid volume, osmotic pressure, and blood pressure. Now, hormones of the adrenal medulla. The adrenal medulla secretes two hormones called adrenaline or epinephrine and noradrenaline or norepinephrine. So these are commonly known as catecholamines. Adrenaline and noradrenaline are rapidly secreted in response to stress of any kind and during pregnant emergency situation and are called emergency hormone or stress hormone. So this hormone is also known as fright, fight and flight. It is stimuli that yes. So fright, during fearless, during fight, action, and during flight, go away. That is bhavja. Okay. So that is why this hormone is known as stimuli that CS. These hormones increase alertness, pupillary dilation, piloerection, sweating, etc. So both the hormones increase the heartbeat, the strength of heart contraction, and the rate of respiration. This is very important in class 10 also. What changes takes place in our body when adrenaline hormone is secreted?
When somebody has not brought one more copy and they want to give the card
Yes, yes.
then
Then
just ask him the symptoms.
under stress.
Ah, if the file is gone, he will be in the same stress. Yes.
Same stress.
Next.
Next, catecholamines also stimulate the breakdown of glycogen, resulting in an increased concentration of glucose in blood. In addition, they also stimulate the breakdown of lipids and proteins. Pancreas is very important and interesting hormone. Whatever we have discussed that this gland is act as both endocrine and exocrine organ. Pancreas is a composite gland which acts as both exocrine and endocrine gland. The endocrine pancreas consists of islets of Langerhans. and there are about 1 to 2 million islets of Langerhans, and out of which 1 to 2% of the pancreatic tissues are present. So the two main types of cells in the islets of Langerhans are called alpha cells and beta cells. Although delta cells are also there. The alpha cells secrete a hormone called glucagon, while the beta cells secrete insulin. Glucagon is a peptide hormone and plays an important role in maintaining the normal blood glucose levels. Whereas insulin is also a peptide hormone which plays a major role in the regulation of glucose homeostasis. So we can say that the action of insulin and action of glucagon is antagonistic with each other. So insulin lowers the blood glucose level, whereas glucagon raises the blood glucose. Next ovaries. Two groups of female sex hormones are produced in the ovaries, the estrogens and progesterone. These steroid hormones contribute to the development and function of the female reproductive organs and sex characteristics. At the onset of puberty, estrogen promotes the development of the breast, distribution of fat evidence in the hips, legs, and breast, maturation of reproductive organs such as the uterus and vagina. Progesterone causes the uterine lining to thicken in preparation for pregnancy. Together, progesterone and estrogen are responsible for the changes that occur in the uterus during the female menstrual cycle. Testis, male sex hormones as a group are called androgens. The principal androgen is testosterone, which is secreted by the testis. Production of testosterone begins during fetal development, continues for a short time after birth, merely ceases in childhood, and then resumes at puberty age. This steroid hormone is responsible for the growth and development of the male reproductive activities and structures, increased skeletal and muscular growth, enlargement of the larynx accompanied by voice changes, growth and distribution of body hair, and increased male sexual drive. Next, some extra organs that also secrete hormones other than endocrine glands. It has already been in the syllabus of class 11. So, hormones of heart, kidney, and gastrointestinal tract. As you know about the endocrine glands and their hormones, however, as mentioned earlier, hormones are also secreted by some tissues which are not endocrine glands. What are these? Number one, heart. For example, the atrial wall of our heart secretes a very important peptide hormone called the atrial natriuretic factor, that is also known as ANF, which decreases the blood pressure. When blood pressure is increased, the ANF is secreted, which causes dilation of the blood vessels, and this reduces the blood pressure. Next, kidney. From kidney, the juxtaglomerular cells of kidney produce a peptide hormone called the erythropoietin, which stimulates the erythropoiesis, that is formation of RBC. Next, gastrointestinal tract. Endocrine cells present in different parts of the gastrointestinal tract secrete four major peptide hormones, namely gastrin, secretin, cholecystokinin, and gastric inhibitory peptide. Several other non-endocrine tissues secrete hormones called growth factors, and these factors are essential for the normal growth of tissue and their repairing or regeneration. Next, placenta is very important. In class 10 students also, some hormones are secreted, so many hormones are secreted. Human chorionic gonadotropin hormone or HCG. This hormone is only made during pregnancy by placenta. It is made almost exclusively in the placenta. It also secretes human placental lactogen, HCl, estrogen, and prolactin. Then the next segment is about the mechanism of action. So before it, we should know what is cell signaling. The effects of hormones depend on how they are released. Hence, signaling effects can be classified into the following four categories. Number one, autocrine. So when the hormone acts on the same cell that produced it, such type of signaling effect is known as autocrine. Next, paracrine. The hormone acts on a nearby cell without having to enter into the bloodstream. Such type of signaling effect is known as paracrine. Next, number three, intracrine. When the hormone is produced in the cell and acts intracellularly, means inside the cell, such type of signaling effect is known as intracrine. And last one is endocrine. So when the hormone acts on the target cells, once it is released from the respective glands into the bloodstream. So these are the mainly four types of signaling, cell signaling, how hormones signals. So now mechanism of hormone action. Hormones produce their effects on target tissues by binding to specific proteins called hormone receptors located in the target tissues only. Only that receptors are present on the target tissues. And hormone receptors present on the cell membrane of the target cells are called membrane bound receptors. And when the receptors present inside the target cells are called intracellular receptors. So there are mainly two types of receptors. Number one, membrane bound receptors, and number two, intracellular receptors. Mostly intracellular receptors are mostly nuclear receptors that are present inside the nucleus. Binding of a hormone to its receptor leads to a formation of a hormone receptor complex. Just like enzyme substrate complex, lock and key system. Here also, hormone and receptor, they also make a complex. Each receptor is specific to one hormone and hence receptors are specific. Hormone receptor complex formation leads to certain biochemical changes. In case of enzyme action also we have learned so many changes when substrate bind with the enzyme, then so many biochemical changes take place. In the same way, here also, each receptor is specific to one hormone only, and hence receptors are specific. And hormone receptor complex formation leads to certain biochemical changes in the target tissue. Target tissue metabolism and hence physiological functions are regulated by hormones. Next, fixed receptor mechanism. Two types of receptor mechanism of action: fixed receptor mechanism and mobile receptor mechanism. So this mechanism of hormone action is seen in the protein hormones. such as follicle stimulating hormone, adrenaline hormone, insulin, ADH, TSH, etc. Hormones which interact with membrane bound receptors normally do not enter the target cell. But generally, second messengers, for example, cyclic AMP, IP, calcium ion, etc., which in turn regulate the cellular metabolism. As mentioned earlier, since they are water soluble, they cannot pass through the cell membrane because it is made up of cell membrane is made up of lipid bilayer. So they bind to their extracellular receptors present on the cell membrane, not inside the cell membrane. Once the protein hormone binds to the receptor, a series of reactions occur, beginning with the production of adenyl cyclase enzyme. This enzyme leads to the production of cyclic AMP or CAMP, which is the secondary messenger. This CAMP can now enter the cell and cause the effect it was meant to bring about. So hormone directly cannot enter inside the cell membrane. That means second messenger bring the hormone into the nucleus. Next, mobile receptor mechanism. This kind of mechanism is seen in the steroid, that is what? Fat soluble hormone, steroid hormone, that is insoluble in water but soluble in fat. So they are made up of fats and therefore can freely enter the lipid layer of the cell membrane. Their receptors are intracellular and not extracellular like those for the protein ones. In protein, in case of protein hormones, they are extracellular, but the, here their receptors are intracellular and not extracellular. The intracellular receptors can be floating in the cytoplasm, on the nuclear membrane, or inside the nucleus. And for this reason, their receptors are known as mobile receptors. Hormones which interact with intracellular receptors, that is steroid hormones, iodothyronines, etc., mostly regulate gene expression or chromosome function by the interaction of hormone receptors complex with the genome. And cumulative biochemical actions result in physiological and developmental effects. Next, feedback mechanism of hormone regulation. Without hormone and hormone mechanism of hormone action cannot be completed. I think. Feedback mechanism of hormonal regulation. The hormone feedback mechanism is the mechanism that keeps the hormone balance. So, how much hormone is secreted and at what time it is secreted, that all these are under controlled condition. So that is called actually feedback mechanism. So increased or decreased hormone concentrations can occasionally stimulate and promote hormone release or inhibit hormone secretion. This is known as feedback system or feedback mechanism. The majority of hormones released by endocrine glands are controlled by feedback mechanism. A feedback mechanism is a loop that a product feeds into in order to manage its own production. Positive, there are two types of feedback mechanism, positive and negative feedback mechanism. And positive feedback stimulates and increases hormone secretion. So in case of positive feedback mechanism, hormone secretes, the rate of secretion of hormone increases. Whereas in case of negative feedback, stop or inhibit the secretion of hormone from the respective or definite endocrine glands. Next. So feedback mechanism of hormonal regulation, for example, hormonal regulation of insulin. When we eat carbohydrate-rich food, the level of glucose in our blood rises, as you know it very well. So as blood glucose levels rise, the pancreas produces and releases insulin. It will cause the cells to absorb more blood glucose, and this is the method via which blood glucose levels occur. When insulin is present in the blood, more glucose is carried into the cell and resulting in a glucose shortage in the blood. Whereas low glucose levels restrict insulin secretion in the circulation, causing negative feedback to prevent glucose shortage. That's all, sir.
Very nice, very excellent.